All right, today we're going to dive into something really cool. A new model that might finally crack the code on how our brains actually remember stories. I mean, have you ever thought about this? You can tell someone the entire 2-hour plot of a movie, no problem, hitting all the key points. But if someone asks you to recite even one scene word for word, yeah, no way. So what's going on there? It seems like a simple question, but it points to a huge mystery about how our memory really works. Yeah, it's pretty obvious our brains aren't just hitting record. They're more like expert story editors, constantly compressing and summarizing everything. But the big question is, how do they do it? Is it just random? Turns out, no. There seem to be some actual rules our minds follow when we listen to a story and then tell it back. So, to solve this puzzle, researchers started by looking for clues in the data. They just observed how people actually recall stories. And you know what? They found some very consistent, very interesting patterns. Okay, so here's the first big clue. As a story gets longer and longer, our summary of it doesn't just keep growing at the same speed. Nope, it grows for a bit, and then it starts to plateau. It's like our memory hits some kind of soft limit. There's a name for this, of course. Scientists call it sublinear growth. All that really means is that as the story gets way longer, our memory of it just doesn't keep up. It flattens out. This isn't some weird quirk, it's a fundamental signature of how we remember narratives. Now, to really get what's happening, we need this one key idea, the compression ratio. Sounds fancy, but it's super simple. It's just the amount of the original story that gets packed into a single sentence of your summary. And this is the really cool part. When we're faced with a super long story, our brains don't just get worse at remembering, they actually get better at summarizing. We become way more efficient, cramming more and more information into each sentence we remember. That compression ratio, it goes way up. So we've got these two clues, right? Our recall flattens out and our summaries get denser. What kind of theory could possibly explain both? Well, that brings us to a new idea, the memory tree model. The beauty of this model is that it's built on two really simple ideas. First, encoding. As you listen to a story, your brain isn't just saving a long string of words. It's building a kind of family tree of ideas, a whole hierarchy. Then, step 2, recall. When you go to retell the story, you're basically just taking a walk along the main branches of that mental tree you built. You can literally picture it like this. The whole story is the root of the tree. From there, it branches out into the major ideas, and then those branches sprout smaller details, like leaves. Our recall, the story we tell back, is just the path we trace through that tree, hitting the big points along the way. Now here's where it gets really wild. What if I told you that this entire complex process might be governed by just one single number? And that number is 4. And no, this isn't some random number they pulled out of a hat. 4 is widely thought to be the average number of things we can hold in our working memory at one time. The model proposes that this fundamental limit is what controls our recall. It dictates how many branches of the story tree we can explore at once and how deep we can go into the leafy details before our brain says, well, that's enough, time to summarize. So, an elegant theory is one thing, but does it actually work? Does it hold up in the real world? Let's see how the memory tree model actually stacks up against the data. And wow, check this out. The red line on the graph is what the model predicts. The blue dots, that's the actual data from human experiments. It is a near perfect match. That flattening curve we saw earlier, this simple tree model predicts it perfectly. But it gets even better. The model doesn't just predict how much we remember. It also perfectly predicts our second clue, that compression ratio. The model's predictions for how much we summarize line up beautifully with the real-world data. It nails both of the key patterns we see in human memory. And what's maybe most convincing is that the model wasn't tweaked or adjusted to get this result. Its predictions just emerge naturally from those two core ideas, the memory tree structure and that working memory limit of 4. And that is what makes this theory so powerful. Okay, so the model works. That's great, but let's zoom out a bit. What does this really mean for how we understand our own minds? Why does this matter beyond the lab? Well, here are the big takeaways. First, our memory isn't a recording, it's an active process of building a structured summary. Second, it seems we automatically build these mental tree hierarchies to make sense of the world. Third, our basic cognitive limits, like working memory, directly shape how rich our memories can be. And finally, and this is just amazing, it shows that a really complex human behavior can be predicted by a surprisingly simple framework. As the researchers themselves put it, this all highlights the critical role of working memory capacity in controlling narrative recall. In other words, a fundamental limit of our brain seems to be the master architect of the stories we tell ourselves. And that leaves us with one last, really provocative thought. If our memory for stories is built on these hierarchical trees, what else is? Could our memory for our own lives, our understanding of history, or even our complex social relationships, could they all be organized by these same hidden mental structures? It suggests a whole new way of looking at how we build our inner world.